many have asked about the laser welder and how does it actually operate. So I just want to take the time and talk through what is actually happening with a laser welder. Our Maxphotonic units come in two series, either a multi-mode pulse laser or a single module pulse laser. What sets a good laser welder apart from a mediocre one would be how is that power being relayed. And many guys use a constant laser which is actually meant for cutting, and they put them on laser welders. But ideally, if you want a really strong, good penetrating machine, you need to use a pulse laser to get the penetration. The latest in pulse lasers is a single module pulse laser. And what's happening is the module is producing light. The light then flows through a fiber optic cable, that fiber optic cable is like a glass cable which transports the light through your fiber optic cable up into the torch. If you can get a good angle on that. So your laser beam gets shot up here. There are a series of optics in the torch. You've got a culminating lens at the bottom. It's then the laser beam gets shot through the culminating lens. This culminating lens is convex, which reduces the laser beam size into a smaller size. It will then hit a mirror, which is in the back here. This mirror is attached to a little motor, which allows it to oscillate. That mirror then would reflect it through the front of your torch. And in the top of your torch, you have three more lenses. You have a focus lens, a protective lens, and then another protective lens. With laser welding, your consumables are always going to be optic. Your optics are going to be what you're going to have to change from time to time. So the laser beam hits the mirror shoots it out that way. Because this little mirror can oscillate, it allows the laser beam to wobble in front, side to side. This gives, and because I've got control of the motor, it gives me the ability to control how broad is the beam, how broad I want it to wobble from side to side, of which the 1.5 kilowatt X1 machine can go up to 4 mil bead, or as little as 0.5 mil bead, a very thin weld. And I can, because I've got control over this mirror, I can also determine how fast I want it to wobble. This will give me different finishings, and without getting too technical, because it's pulsing, you can either get the pulse on the sides, and if you speed the wobble up, you'll move that power band into the middle, which can give you different finishings. So that in a nutshell, this focus lens that is here takes that laser beam and reduces it to an even smaller dot. So now you've got all this power concentrated on a small dot, which while you're welding, as the wire's pushing you along, the laser beam is wobbling and burning your wire into the section where you're welding. Of course, we're using nitrogen to cool the torch. So now inside this cable, if you can see here, inside the cable, you've got 3 cables running in here: an air cable, a communication cable, and your fiber optic cable. The nitrogen gas, which is preferred gas for laser welding, serves 3 purposes. Firstly, it is cooling the culminating lens down. Now, with a water-cooled unit, they'd use water to cool the culminating lens down. But I always advise the guys that, the first place of wear and tear is going to be here where your torch lead meets the torch. And with a water-cooled unit, you've got many pipes running in here. It's a big, thick communication pipes. So firstly, it's a very bulky, big torch when you're using a water-cooled unit. The other issue is, because you're cooling down with water, the first place it will start leaking is here. And if it starts leaking, you may start getting, rusting. The next problem you might get is your optics getting dirty. And so ideally you want to eliminate it, and that's why air-cooled laser welding is the future. And I think in the future all laser welding machines will eventually be air-cooled machines. There's no maintenance. With a water-cooled machine, you're going to have to change water from time to time and repair water leaks. So those are just a few things to keep in mind when shopping around for a laser welder. What sets a good laser welder apart from mediocre is your dot size and the way it's delivering the power. Dot size is when they've built the laser power source, they've calibrated it exactly right, that the power of the light is exactly in the middle. That determines your dot size. And the more accurate they get that set in, the more powerful the laser will be. So that's just, I don't want to get into too much detail, but that's exactly what's happening in the torch. And like I said, you are welding with an extremely powerful light source, not with electricity. And so this is the future, and I hope that opens your minds as to what's actually happening with laser welding and gives you a good understanding of what it's doing.